So in this video, we'll take up the first of two homework sheets on linear systems or problem solving with linear systems. So a bunch of word problems. I like this sheet because some of the questions on the sheet are not the four types that we talked about in the handout. So they don't fall in the category of coins, investment, mixture, or rate. Like I like the first one. It's just a number problem. We have a ball problem. So I like that because I don't want you memorizing how to solve a word problem. Just read the question and just do it. Okay, so my general strategies for all these are let statements, generate the system, and then solve it. And of course, write a therefore statement. So not really much to say. Your system can look different, or the equations that make up the system may look different because as long as the equations are equivalent, then you are correct. Like then we'll get the same solution because the systems will be equivalent. Even though they look different, they're still the same system. Like I wrote x minus y equals 2, you could have wrote x equals 2 plus y. Or you can write y minus x equals negative 2. There's a lot of combinations here. You can rearrange the terms however you want, and the equation will still be the same. All right, so there's our first question here. Not much to say. The second question is about basketball and soccer ball. So 3 soccer balls and a basketball is 155. 2 soccer balls and 3 basketballs is 220. So you can solve for this number of basketballs and soccer balls. Okay. In number 3, we're just selling chocolate bars and chocolate covered almond boxes of chocolate covered almonds. Yeah, so that to me is very similar to number 2. You're just selling some different things, but you're still selling stuff. Yeah, so there's not really much for me to add there. A plus C. Yeah, so this is a box and a chocolate bar is $96. Wow, it's very steep. Anyways, I'll let you study that. For number 4, this is a grade 9 problem, really. It's a grade 9 problem. You have 2 companies. One is going to have a higher initial cost, but a better rate, and then vice versa. So if you print 150 pages, then both companies cost $1,000. Now, if you want to print 175 pages, now since 175 is greater than 150, the 150 that I solved in part C, then you should choose a company that offers a lower rate, because lower rate means better in the long run. Now, long run is very, you have to interpret that. But since you solve for the point of intersection, then you know what long run means. Long run means greater than 150 pages. So anyways, choose the company with the lower rate. All right. Sorry, I want to jump back here. The other way to do this question is just solve for the cost. Like let n equal 175 for both the equations, and then you'll see that the cheaper company is the one that indeed offers the lower rate. Okay, number 5. Oh, this is an investment problem, so not much to say. The total investment's $4,000, and the 11% investment does $212 better than the 8% investment. Okay, so it's number 6. Oh, we have a regular hourly rate and an overtime rate. So 38 hours of the regular hour rate plus 7 hours of the overtime rate is $833, and then 38 hours of regular hourly rate and 2 hours of overtime rate is equal to $713. So you can solve for the rates. A good let statement really makes this easy. All right, 2 more problems here. 7. So n represents the number, the cost per day to rent a car. And R represents the cost per kilometer. To solve the system, so if you rent for 1 day and you drive 240 kilometers, you get charged $39. If you rent for 5 days and travel 900 kilometers, you get charged $165. Anyways, you end up seeing that it's $150, sorry, $15 per day and 10 cents a kilometer. So time spent playing tennis and time spent cycling in minutes. So just looking at the energy burned. The total energy burned is 1450, and they give you the rate at each is burning calories, and then they also tell you the total time played is 50 minutes. So solve the system, and you find that you spend 20 minutes cycling and 30 minutes playing tennis. How you solve the system is really up to you. You can do substitution or elimination. So I think I tried to give you a variety. So when you see my solutions, you didn't just see one strategy. Okay, hopefully you're able to solve all the systems.